Okay, so in this video, we're going to talk about writing exponential functions. So this is similar to yesterday, but we're going to talk more about tables today. So exponential equations are written in the form y equals a times b to the x, where a is the initial value, b is the growth or decay factor, and then either b minus 1 or 1 minus b is the growth rate. Okay. For exponential growth, your b has to be bigger than 1. For decay, b has to be between 0 and 1. Okay. So that's a review of yesterday. So let's look at that again. So for example, here's my equation, y equals 3.7 parentheses 2 to the x. Would that be growth or decay? That would be growth because that 2 is bigger than a 1. What is your growth factor? Your growth factor is 2, and then your initial value would be 3.7. Okay? So how to create a table of values? Let's start with my initial value of 0, 3.7. Okay? So at 0, I'm going to be at 3.7. Let's get some other numbers before it and then after 1. Okay? So if they are going by 2, that means they're going to be multiplying by 2. So 3.7 times 2 is 7.4. So again, we're going to times by 2 and get 14.8. Okay? So that's how you go forward in a table, given the growth factor. To go backwards, the opposite of multiplying is dividing. So you're going to divide by 2 and get 1.85. You're going to go backwards and divide by 2 and get 0.925. Okay? So again, if you're going forward in a table, you are multiplying. If you're going backwards, you're going to be dividing. Okay? So let's look at some examples. So here's a table, and I need to determine if it is growth or decay, and find the growth factor and the initial value. So what I notice is I'm going to look at these y columns. I notice they are getting smaller. Okay, so that is that's a key that it's going to be a decay problem. Okay, to determine if it is exponential growth or decay, you need to pick a number and divide it by the one before it. So for example, let me pick 27. I would do 27 divided by 81, the one before it. And you're going to get a decimal, I believe it's 0.3333. If you hit math, enter, that's going to give you 1/3. Okay? So again, you're going to pick a number and divide it by the one before it. So you should get, again, that repeating decimal. If you hit math, enter, you're going to get 1/3. So same thing, pick a number, divide it by the one before it. You should get 1/3. Pick a number, divide it by the one before it. You should get 1/3. Okay, so yes, that is an exponential function. They are dividing the whole time, or you could say they're multiplying by 1/3 each time. The growth factor is going to be the number that they're going up or down by. So in this case, they are multiplying by 1/3 each time. To find your initial value, that's going to be when x is 0 in a table. So my initial value was at 81. Okay. So now that you have your initial value and you have your growth factor, you can write your exponential equation. So remember the generic formula is a times b to the x. So in this case, I'd start with y equals 81. You can put times or parentheses. I'll do 1/3 because that's your growth factor and raise it to the x. Okay. So that is how you find an equation from a table. So again, you need to find the growth factor first. And you do that by picking a number and dividing it by the one before it. Hopefully they've given you your initial value, or you can keep finding it by multiplying. So let's look at some more problems. Example 2. Those look a little tricky because there are a lot of decimals. So again, I need to pick a number and divide it by the one before it. So let me start with this number. So I would do 29.04 divided by 13.2. Okay, when you get that, I got 2.2. And we can leave that in a decimal since it's not repeating. So what that means each time is they are multiplying by 2.2. They're multiplying by 2.2. And you can keep checking it, like I said, and pick a number. So you can do 140.555 and divide it by 63.888, and you should again get 2.2. Okay? So is this an exponential function? Yes, because they are timesing by 2.2. So if you're multiplying or dividing, that is exponential. Is it growth or decay? I noticed that these numbers are getting larger as I'm going up. Also, I noticed my growth factor was higher than a 1. So it is going to be a growth. Again, your growth factor is 2.2, what you found. Now your initial value is when x is 0, but notice they didn't give me an x equals 0. So I need to go backwards. Okay? So in the past, we've subtracted or added going backwards, but with exponential functions, you have to multiply or divide. So since they are multiplying this way, I'm going to divide going backwards. So I would do 13.2 divided by 2.2. Okay? So again, 13.2 divided by 2.2, and you should get 6, which is a nice number. Okay? So my initial value is 6, my growth factor is at 2.2. I can write my equation. So I start out with y equals your initial value, which is 6, parentheses, your growth factor, and then x. Okay? So just a lot of work dividing. Let's look at another example. All right, is this exponential? I don't know yet. Let me see. I do notice that these numbers are going down, so I'm going to go ahead and say that it's decay. But to find that factor, again, I'm going to pick a number. So I'm going to pick this number and divide it by the one before it. So I would do 78.64 divided by 125.83. Okay? When you get that, you should get 0.625. Again, you can make it a decimal or a fraction, or you can leave it as a decimal. I'm going to leave it as a decimal. So my factor is going to be 0.625. And again, we can check that with another number, for example, and do 30.72 divided by the one before it. And again, you should get 0.625. All right, so that means it is exponential. So now I need to find my initial value. This is going to be a little bit tricky because they did not give me when x is 0. I actually have to go back twice. So in this case, if I go back once, I would be at x equals 1. And so I'm going to go back here first. So notice they were dividing by 0.625 because it kept getting smaller. So when I go backwards, I'm going to actually times by 0.625. So 125.83 times 0.625. Oh wait, no, I'm dividing. I'm so sorry. So sorry. They are actually timesing by 0.625. I apologize. So you're timesing when you're going down. So if I go backwards, I would divide by 0.625. So 125.83 divided by 6.25, 625 is 201.328. Okay? But again, I'm not done. I have to go back to find the 0 value. So again, I'm going to divide that number by 0.625, and then I would get 322.1248. Okay, so now I have found my initial value. Let me write it over here. Okay, so once you did all that work for finding your initial value, you can write your equation. So y would equal, your initial value is going to go first, followed by the parentheses, which was 0.625. And don't forget to raise it to the x power. Okay. All right. One more problem and we're done. All right, so it says, given the following data from a largemouth bat's population in a local pond below, find the exponential equation that models the situation and let 0 represent year 1970. So what that means is this is year 2, 3, 4, 5, 6, 7, and 8. Okay, so first thing, I need to find the growth factor. Okay, so to do that, I'm going to pick a number. So let's pick this number. So I'm going to do 322 divided by the one before it, which is 200. So 322 divided by 200 is 1.612. So that is my growth factor. Okay, you can check it, and so you can do 519 times 1.62 times 1.612, and hopefully you are going to continue to get those numbers. Okay, so now I need to find my initial value. To do that, I'm going to have to go back twice. So again, if I go back once, I'm at when x equals 1. So I need to go back here. So I'm going to do 200 divided by my growth factor, which is 1.612, and you're going to get 124.07, and I have to do it again. So I'm going to go back again to find my starting point, and again I'm going to divide by 1.612. So 124.07 divided by 1.612 is going to be 76.97. So now I have my initial value of 76.97, and so I can finally write my equation of y equals your starting point, which was 76.97, with your growth factor 1.612, and raise it to the x power. Okay. So you may run into a lot of decimals with exponential growth and decay from a table. The hardest part is going back to find your initial value if they don't give it to you. Again, to find the growth factor, you pick a number and divide it by the one before it. Okay, so that's going to tell you whether they're multiplying or dividing. So again, if your graph or your table is increasing, that means you're multiplying. If in case your graph is, this one was decreasing. If you're decreasing, that's going to be a fraction. And if you're increasing, it's going to be a whole number. Okay. So again, to go back and find the initial value, you divide. Okay. So now you can practice exponential growth and decay from tables. Good luck.